Here is the question from GET 2019 from Quantum Mechanics, and in this question it is given that the wave function psi of x of a particle as shown below. This is the wave function for the particle. Here k is a constant and a greater than d. The position uncertainty del of x of the particle is, four options are given. First option it is given that del x equal to under root a square plus 3d square divided by 12. In option B it is given that under root 3a square plus d square divided by 12, and in option C it is given that del x equal to under root d square divided by 6, and option D is given as del x equal to under root d square divided by 24. So for solving this question, first of all we will plot the wave function psi of x for the given graph. For the given graph, as we are seeing that psi of x can be defined as psi of x equal to k when it ranges from, as we are seeing that this value is a divided by 2 and this value is d. Therefore we can write this length will be equal to d divided by 2, and also this length will be equal to d divided by 2. Again this length will be equal to d divided by 2, and this much length will be equal to d divided by 2. So from this condition we are seeing that k psi of x will be k when a plus minus a divided by 2 minus d divided by 2 less than x less than minus a divided by 2 plus d divided by 2. And again this value of psi of x is valid when the wave function lies in this region. After this region the value will be equal to 0, and its range is equal to minus a divided by 2 plus d divided by 2 less than x less than a divided by 2 minus d divided by 2, because this is 0 in this region, from this to this region. And after that this is again the value of psi of x will be again equal to k, and for this k its range will be equal to minus will be equal to a divided by 2 minus d divided by 2 less than x less than a divided by 2 plus d divided by 2, and it will be again 0 beyond its left side and beyond its right side. So it will be again 0 when the mod of a divided by 2 plus d divided by 2 greater than 0. So therefore now we can write in the Dirac bracket notation. In Dirac bracket notation, we can write psi slash psi will be equal to 0, and from this equation we can write, if we expand this will be not 0, this will be 1, and value of this function will be equal to k square integration of dx from this range is equal to minus a divided by 2 minus d divided by 2 to minus a divided by 2 plus d divided by 2 plus k square integration of dx again, and it ranges from a divided by 2 minus d divided by 2 to a divided by 2 plus d divided by 2. So if we calculate this value, then its value will become equal to k square multiplied by k square into x, and limit of x will be equal to, lower limit is equal to minus a divided by 2 minus d divided by 2, and upper limit is equal to minus a divided by 2 plus d divided by 2 plus again k square and x, and lower limit of this x equal to a divided by 2 is equal to a divided by 2 minus d divided by 2, and its upper limit is equal to a divided by 2 plus d divided by 2. Now if we carry out this integration, then its value, and again we know this value is equal to 1, so this value will be 1. So if you calculate this value, then its value will be equal to k square will be common, and its value will be d divided by 2 plus d divided by 2 plus d divided by 2 plus d divided by 2, which will be equal to 1. So from this equation we can write k square into 2d will be, k square into 2d will be equal to 1. Therefore we can write k square equal to 1 divided by 2d, or we can write the value of k will be equal to 1 divided by under root 2d. This is the value for k. Now we are seeing that the wave function is symmetrical about the wave function as the wave function psi of x is symmetrical about x equal to 0. X equal to 0 means this y-axis. Therefore we can write the average value of x will be equal to 0. Now we have to calculate the value of average value of x square. For finding the average value of x square, we'll write average value of x square will be equal to k square integration of x square dx, and its limit will be equal to minus a divided by 2 minus d divided by 2. Its upper limit will be equal to minus a divided by 2 plus d divided by 2 plus k square integration of x square dx, and its limit will become a divided by 2 plus minus d divided by 2, and upper limit will become a divided by 2 plus d divided by 2. Now if we carry out this integral, then its value will be equal to k square divided by 3 into, it is multiplied by x cube, and value of x cube and limits of x cube will be equal to, lower limit is equal to minus a divided by 2 minus d divided by 2, and upper limit is equal to minus a divided by 2 plus d divided by 2. Again there is again 1 x cube, and its value, its limit is equal to, lower limit is equal to a divided by 2 minus d divided by 2, and upper limit is equal to a divided by 2 plus d divided by 2. So if we calculate the value of this integral, then its value will be equal to mean of x square will be equal to k square divided by 3 into 8, because 8 terms comes because here is a square divided by 2, d square divided by 2, there is a half everywhere, and cube of half equal to 1 by 8. Therefore it will be k square divided by 24, and again there will be value of minus a divided by 2 plus d divided by 2. There will be minus a divided by 2 plus d divided by 2 whole cube, minus, there will be plus, and there will be minus a divided by 2 plus d divided by 2 whole cube, plus a divided by 2 plus d divided by 2 whole cube, minus a divided by 2 minus d divided by 2 whole cube. So if we calculate this value, then its value will be equal to mean of x square will be equal to k square divided by 24 into, and it is multiplied by this. Now we have to expand this term. If we expand this term, then its value will be equal to a divided by 2 cube means minus a cube divided by 8 there will not will be 2, because we already take 2 outside from every term. So there will be minus a cube plus d cube plus 3 a square d plus minus 3 a d square minus 3 a d square, and the next term will be equal to minus a cube, and this minus and minus will be equal to plus, this will be plus a cube minus d cube a square. Next the term will be equal to minus 3 a square d, and its next term will be equal to 3 a d square, and its value will be positive. And similarly there will be a value for this expansion. If we expand this term, then this term will be equal to a cube plus d cube plus 3 a square d plus 3 a d square, and this is added with this term, and there is a minus, and if we expand this term, then it will be equal to minus a cube plus d cube plus 3 a square d minus 3 a d square. Now if we collect all this term, then its value will be equal to k square divided by 12. So mean value of x square will be equal to k square divided by 24 into, and it is multiplied by 4d cube divided by 12, 4d cube divided by plus 12 a square d. Now if we put the value of k square, because value of k square equal to 1 divided by 2d, then we can write this value will be equal to 1 divided by 24 into, and from this term 4d is common. If we take 4d is common, then our remaining term will be equal to d square plus 3a square divided by, and as we know value of k square equal to 1 divided by 2d. So if we calculate this d will cancel, this 2 and this 4 will cancel, and there will be 12. So mean value of x square will be equal to d square (3a square) plus d square divided by 12. Again we have to calculate the value of the position uncertainty del x. For finding the position uncertainty, this del x will be equal to under root mean value of x square minus mean value of x whole square. Now as we know, the mean value of x square is given as equal to 3a square plus d square divided by 12, and the mean value of x equal to 0. So its ultimate value will be equal to, therefore we can write del x will be, del x means the position uncertainty, that will be equal to under root 3a square plus d square divided by 12. Now as we are seeing that here is 4 options are given. In first option its value is a square plus 3d square by 12. In second option it is given that del x equal to under root 3a square plus d square divided by 12. In third option it is d square divided by under root d square by 6, and in fourth option it is given that under root d square divided by 24. Among these four options our correct answer is matching with option number B. Therefore we can write option B is correct. Therefore we can write option B is correct. Hence this is answer.